Good afternoon, Jan.
Michael, good afternoon. How are you?
Doing well. Doing very well.
I doing fine also, the meanwhile.
Excellent. Yeah, getting ready for the holiday season. So um, a lot of a lot of little things to do to prepare for the kids coming home and
Mhm.
just spending some time trying to set things up to enjoy life a little bit.
That's a good idea. But you will still be programming, I know.
Oh yes, yeah, yeah. That is a big part of an enjoyable life.
Mhm. Yeah.
Yeah, sometimes I try to put myself back, just 100 years. Certainly like 200 years, even longer. It's like you're doing things day to day, but nothing is computing. You're not. You know, what
Mhm.
are you doing? It's like, yeah, I need a thing around me that calculates stuff,
Mhm.
that automates, and yeah, yeah, that's yeah, yeah. I sometimes have like when I'm talking with the high school kids about programming, I'm
Mhm.
trying to impress upon them the fact that the things that you use every day that run on your iPad and on your phone and on your laptop, um, somebody else made those decisions. Somebody else made that, and you might enjoy using those programs, but you would the thing that you really want to do, it doesn't do because they weren't you. They didn't make the same decisions. And so you have this power. You can build something that works exactly the way you want it to.
The way you want it. Yeah.
And yeah, that's a, that's a that's a real power that I wish that
Mhm.
everybody else had and understood.
They can change things and that they can influence the way the world runs,
Mm-hmm.
at least on the technical side.
Yeah. Oh yeah. Yeah. Yeah.
Yeah. No, and also that what they use today has not always been there.
Right. Yeah.
Yeah. If you see the difference, 20 years ago, we hardly had any mobile phones.
Mm-hmm.
There was no Android. There was no Apple. Yeah, Apple was there, but the iPhone was not there. So.
Right. Yeah. Yeah. When I was in Colorado, I was telling my son that yeah, I was working at a mobile app development company when the
Mm,
iPhone launched, and I remembered the meeting that the executives called. Okay, all hands, everybody's in this meeting. We're going to talk about this new iPhone thing, and of
mm,
course, all the executives pull out their iPhones and start showing us, and we're like, yeah, we can't afford one of those things, not with what you pay us. Um, we've got
mm,
our BlackBerry devices for testing our apps, um,
mm.
but uh, but yeah, it's like to think of a world before an iPhone. He was just like, "Whoa, I guess so." But then, yeah, going even further back, I was talking about the people who founded our industry. Um,
Mhm,
I was telling him about Claude Shannon,
mhm.
and I believe Claude
Information
Shannon is still
theory.
around. I think,
He must be old in
yeah.
meanwhile. Yeah.
And yeah, I was telling him I saw Tim Berners Lee give a
Mm,
presentation, just last year. Um, yeah, and it's like this is the person who created the internet as you know it. Yes, there were others. He didn't create TCP/IP, but yeah, the web browser, HTTP, HTML.
mm.
Yeah,
Even Albert Einstein. He died in '69, no, or something around that.
that sounds about right. Yeah.
I think he was still alive when I was born.
Hmm. Yeah, I was born just after that, so
So
yeah.
couldn't talk to him, but
Mm-hmm.
no, but I just saw a mail coming in. Yeah.
Oh yeah,
What?
I've been doing a whole bunch of stuff trying to see
Mm,
how much I can demonstrate today.
okay. I'm getting in a mail from a customer.
Oh,
everything works.
oh,
Everything works. That's a good one.
hey.
No, I had let's call it a nightmare week,
Oh,
which tells me, Jan, you need historical modeling.
mm-hmm,
Why? Very easy. Um, no, the DWS software is still working on this sync framework thing.
mm-hmm.
Sync framework, which is a long time ago, but
Yeah.
nobody knows it anymore. No, Microsoft doesn't support it anymore. And so, beginning of the week, a customer called me. He said, "When we create a new user, so when they go for holiday and they don't sync long enough, then the retention period is expired, and so they have to re-download all the data,
Yeah.
and that doesn't work. It was no silence. We're gonna. The phones are ringing. That's not a customer. That's publicity.
Ah.
So, um, um, so this sync framework thing, it works fine, but then a customer called me evening. Yeah, Jan, I couldn't create a new user. He was not in the office anymore. I was not. So I say, strange. You probably did something wrong. You want me to call you back this evening because I was not in my office?
Mm-hmm.
No, tomorrow. Okay. That evening I looked to the monitor screen and I said, strange. There are two people who are having that problem. I tried it myself and it didn't work.
Mm.
That's a red light, but all the users who are synchronizing, it works. So then immediately I started looking, and then I take a backup server, I restore a backup from the day before, and then I look back, and so day to day restoring backups to see when it happens, because I didn't find anything in the logs. And finally I found between that day and that day I had a problem,
Mm.
but searching, and then you see that something goes wrong inside the compiled code from Microsoft,
Oh,
but you don't know what.
yeah.
Finally, because I almost thought I would have to cancel our meeting today, I would still be searching. But finally, I found on the internet another copy of a knowledge base article,
Mm.
which is still already not available. And I found the patch. I installed that, and everything is working again.
Huh.
But there you see the importance of having the source code, because if historical modeling,
Mm-hmm.
if it goes wrong, even if there is no support anymore around, in 50 years time Michael is not there anymore,
Right. Yeah.
well, you can still go into the source code and you can find out what is wrong.
Yeah.
um, while here you're really, I say, yeah, what am I gonna do? um, but okay.
Wow. Yeah. That is a scary moment. Yeah, and and so it was just a change that Microsoft had made in a
Well,
particular version.
no, apparently there was a bug in the software which manifests itself at the moment that you have a certain combination of amount of data with certain fields and data structures.
Okay.
And so, yeah, we reached that point
Mm.
and then it fails. Um,
Wow. Yeah. Yeah. That is tricky. And
yeah. Now it
yeah.
was only for one customer. All the others were still working fine. And okay, they still worked fine, except two users couldn't reinitialize
Mm-hmm.
their system, so it was not a disaster. But if at that moment you have no solution, and then I
Right.
would say, okay, I have to switch today to historical modeling. Um,
Yeah. Yeah. I think the developer experience is good, but it's probably not that fast.
yeah.
Yeah. Wow.
So there I say, okay, historical modeling, I have to switch to it, because with all these old technologies,
Mm-hmm.
uh, which I don't have control over, not completely,
Right.
it's too scaring.
Yeah, yeah, and there's a movement that I've been kind of watching right now, I'm thinking I might start to participate a bit more than I have been. But the local first movement. Um,
Mhm.
so that's um, that was
They want
started.
to have it run on your computer itself first,
Mhm.
or it looks like it runs locally, but it is a remote, a synchronized thing.
Yeah,
Is it that?
yeah. And the so the idea started with a manifesto from Ink and Switch.
Mm.
They're a research company, I guess is the best way to describe them. They've got some products, but they seem to be more focused on doing the research to to come up with with new ideas. Um, but the the core tenets are a combination of technology and social responsibility. So
Mm.
so with the technology, yes, um, it's similar to the offline first movement. In fact, they took their name from offline first, which yeah kind of faded in popularity. But offline first was just about the technology. It's like write your apps so that they work offline. Do that first,
Mm.
and then
Yeah.
make them synchronize. Um, and so local first, um, it said, okay, that's an important technological pillar, but the social responsibility is that users own their data. So it's kind of a
Okay.
response to software as a service where
Mm.
you pay a subscription to use an app, and then you put all your data in their servers, and then when you cancel your subscription, hey, they have your data. They get to do what they want. You have to keep
Mm.
reading the terms of service, and sometimes they even violate those terms of service and sell your data with even though they've agreed not to. So yeah, that whole idea of um, user owns the data, which means the data has to be on their device, their devices. They have to be able to manage it. They have to be able to move it from one place to another. They need to be able to open it up and inspect it. Um, they need to be able to use another app that uses that local data. Um, and so yeah, what you just experienced here is uh, is yeah, I don't know if it's mentioned explicitly in the manifesto, but it's certainly tangential that as a developer, you have to not be beholden to some organization. So if as a developer you use a software as a service solution like Firebase,
Mm.
then there's part of your system that you don't control, um, and you
Yeah.
can't control. You cannot. There is now Superbase. It's a Firebase ish. Uh, I don't think it's one to one like binary or
Mm.
API compatible with Firebase, but it has the same kind of services. So it's like if you've built an app with Firebase, you should be able to install Superbase, run Superbase on your own, and then start using that instead.
Mm.
So yeah, this idea uh, of end user ownership uh, is the ideal. Developer ownership is a good second best, but
Yeah.
you know, um, software as a service ownership, definitely want to get away from that.
I think I mixed up with this offline first, but
Mm-hmm.
indeed this ink can switch it. I saw it a long time ago, and that was probably for the local, the offline first thing. Um, but indeed, it's something important.
Mm-hmm.
um, because that's why I've always tried to stay away from components for user interfaces.
Yeah.
But in fact, a component for a user interface, it's not easy to replace, but still much easier than that
Mm-hmm.
component for synchronization,
Right. Yeah.
because that's the core of the system.
Yep.
So
Yep. A grid view doesn't own the data in the grid.
mm,
You can take that data and put it into a different view,
yeah.
and it'll
Now
work.
here I do have the data, um, but I don't have another solution to sync it.
Mm-hmm.
Uh, yeah, historical modeling, but
Yeah.
not operational yet on my side.
Yeah.
That's my fault, but okay.
Yeah.
But so
So So
But Ink and
yeah,
Switch, if I remember well, they also did some research on user interfaces.
um,
Was that not them?
let me. Yes, because basically the ink part of their
Okay.
name comes
Yeah.
from the idea that you've got here on their website. They've got programmable ink. So let
Ink
me
and
do that
Switch.
share.
Yeah.
There we go. Get that off. Um, so. Uh,
Mhm.
so yeah, they're about more than just local first, but local first is a big part of what they're all about. But uh, yeah, I haven't looked too deeply into their programmable ink kind of research projects. Um, ink
If
base.
you scroll down, you see Pixel Pusher, and that's something with peer-to-peer collaboration.
Yeah.
Something which I kind of looked into a long time ago,
Mm-hmm.
but there was more, I think. Low first push. I remember I found some very nice things on their site. Don't
Yeah.
remember.
The the big one that I find
Ah, um,
interesting
auto merge
is AutoMerge.
library.
Yes.
Yeah, for CRDTs.
Oops, not that one.
Yeah.
AutoMerge. There it is. Boom.
Hmm.
Yeah. So yeah, production software, just these two projects. But yeah, all these research projects we're doing. Yeah. So
Hmm.
AutoMerge is a really interesting idea because this is basically taking a JSON document and um, and making that a CRDT. And it's extensible, so it's like you could take one of the properties and make that a different kind of CRDT. So yeah, like the simplest CRDT is a counter, so it can count
Hmm.
up but not down. And then if I count 3 times and you count 5 times when we merge, we get 8. Um, so you can say, okay, this property of this JSON document is a counter. And then if we both have a copy of that CRDT, that JSON document, then um, then
Hmm.
it merges, and we can see each other's changes. And it also has built in the collaborative text editing. Uh,
Okay.
so yeah, here's the counters, lists, text. Yeah. So with text, you make little changes, just like um, insert text here, remove text there, and then
Hmm.
it merges those changes just like Google Docs, but it put that in air quotes because Google Docs doesn't use CRDTs, and the edge cases show it. But
Hmm.
yeah, this has that built in.
Okay. I remember I looked at it a long time ago, but not in detail. But always came back to historical modeling.
Yeah, yeah. As I look through all of these different local first solutions like AutoMerge, they make a different set of decisions, which means that they end up in a different place. Um, and um, yeah, when I think back through the journey of how historical modeling came about, it's like no, those are the decisions that needed to be made for uh, this domain, this set of use cases. So for business software, for being able to to collaborate on a process, a workflow that really works out, which means and it ended up in a place where historical modeling doesn't really do rich text very well. Um, it doesn't do collaborative text editing. Um,
Hmm.
so yeah, at some point I am going to try to think um, how could I integrate auto merge into a Jinaga solution, so that like the blog example that I keep returning to. What if you could actually collaboratively edit contents of a blog and then say, okay, I'm going to push it. So there's part that's workflow, the publish and the review and the comments and all that. But then there's also a part that's collaborative editing.
Yeah.
So can these work together? I don't know.
Mm-hmm.
But one of the places where different sets of decisions lead to different outcomes is what happens in a conflict. And of course, when you're using CRDTs, the name it says there can't be a conflict; they're conflict-free. But what they define to be a conflict in the literature versus versus what people think of as conflicts, two different things. But when somebody changes a word and somebody else deletes that word, that's people would think of that as a conflict. But of course, the CRDT would converge to one one outcome. So a lot of these systems start with the assumption that there is one value. So yeah, I was hoping to see just kind of a
Historical modeling has a list of values.
So in a historical model, a property cannot have just one value. A query cannot be guaranteed to return just one result. And so by eliminating that assumption, then I can open up a whole bunch of things. And now conflict means more than one result. But when you start with that assumption of a property does have one value, then you have to decide what you're going to do.
With historical modeling, you can have multiple values, so you can have a conflict, but anybody can resolve the conflict at any time.
Yep.
Today, in the future, it doesn't matter.
Yes, indeed. And if I switch to lo-fi, let's see. Yeah, this is... Well, we'll do that for right now. So here I'm on the Local First Software Discord, and this is where I want to hang out and do a little bit more. But on this Show Lo-Fi tab, this is basically where people get to post articles about their local first experiments, and you can see a lot of these are actually local first solutions. So this is what my boss would call a red ocean. There's this idea of the blue ocean strategy. I forget what book it's called. It's probably the book is probably called Blue Ocean Strategy. But the idea being that if you want to compete, you want to. It's better to find a space where you can control the entire message. This is a red ocean where there's lots of activity. All these competitors are already controlling the message, and now stepping into this, the first question is, well, how are you different from X? So how are you different from auto merge? How are you different from this one CR SQLite? How are you different from CR SQLite? But there's another SQLite. I just heard about one that's it's Electric SQL. It's a Postgres-based solution. So the idea is that let's get back to this so that we can talk a little bit better. There we go. Yes, the idea with CR or yeah, we already talked about CR SQLite. With electric SQL, is that if you're already using an application that's built on Postgres, then we're going to synchronize the read side of that to your device. So we'll take the change log, we'll we'll get just the subset that your application needs, and then synchronize that to the device, and then you've got Postgres locally on that device in order to read that information. The right side has to make its way back to the central Postgres database and then sync
Okay.
back.
Yeah.
So, so yeah, there they started with the assumption that you're already using Postgres. Um, so all of the assumptions that Postgres carries with it. A column
So it's
has one
still,
value.
mm, but it's still a local, a centralized solution in that sense that you can lock things in the database because your
Yes.
writing is centralized.
Yes. The
Mm.
yeah. So the all of the uh, concurrency
Mm.
primitives um, that you would use in a database. All the oh goodness, why am I blanking on the official name for this idea? But but yeah, essentially it boils down to the locking. All of those are still in place because you're still writing to Postgres. Um, and then what you do on the client side in order to merge this read data with the change the user's local changes, that's up to you as an application developer. So a lot of times people will stand up a a separate Postgres database and they say, okay, we're going to read from this, and then I'm going to apply changes in this, and then when I see them come through, I can delete them from this one, and then I can just use that one. So there's a lot of manual work that you have to do to make that happen. Or you can say, I'm just going to use this for information that's published out to my users, and then their own personal information won't be synchronized through this method. It'll just be
Mm.
managed somewhere else. So, um, but yeah, a set of decisions that uh, that those authors made about um, what you're starting with. You're starting with Postgres. We're gonna go to there. So yeah, a lot of these are saying, okay, we're starting with objects. We're starting with mutable properties. Um, Starting with with relational, or we're starting with network data. Starting with JSON in the case of auto merge. And then what can we do on top of that? And so I said, okay, I don't want to make any of those assumptions because I don't know what problems they will cause in the future. So let's just talk about what a distributed system can do easily. Let's make those the assumptions. Oh, I can move immutable data around easily. Okay, great. I can do directed acyclic graphs easily. Yeah, there's a nice merge operation on a directed acyclic graph. It's just a set merge. Okay, let's start with that, and then build up from there. So, so yeah, I can answer the question, what makes this different from that? It's usually, you know, it's usually what I just said. But then, of course, in order to make it specific to the question, I have to research that other solution. I have to actually know about, I listened to a podcast and I got enough information about electric SQL that I could say, okay, that's what makes a difference. But yeah, just looking at the website, I wouldn't be able to say, oh, that's what makes it different.
It takes time to research all the different solutions.
Yeah. Let's see, electric SQL. In fact, I have not. There we go. I have not seen the website yet, but yeah, it's you've got your Postgres. Electric SQL is plugged into your existing Postgres. This could be Postgres in the cloud. It could be Postgres on on your infrastructure. You just have to turn on a particular mode, which is usually used um, for backing up, doing a live backup of Postgres into another Postgres instance. But they just plug into that, and then download to mobile app, Edge Worker. That's a really cool use case. Like you've got just an Azure function or a AWS Lambda that's using Postgres out there and just doing its thing, and you just sync to it. But yeah, this one's kind of cool. Web browser. So they can actually sync Postgres to the web browser, and I think that the way that they're doing that is PG Lite. Let's see if they have anything about PG Lite on here. Let's see, PG Lite. Yeah, PG Lite. So this is a WASM build of SQLite. Yeah. So is it SQLite or is it Postgres? No, it's a WASM build of Postgres. Yeah. And so you've got the same API that you have with Postgres, and it's got the full query syntax of Postgres, but it's all storing data in the in the browser or in the local storage, that kind of thing. So that is pretty cool. So yeah, I love all this research. I love all these options. Must admit, I don't really like answering the question. Well, how is yours different from theirs? So okay.
Yeah, but it's good to see that there are so many people in this area looking for solutions.
Mm-hmm.
It means it's really something that is needed.
Yes, indeed. Yeah, it definitely validates the validates the space.
Mm.
So which also makes it kind of interesting to and so listening to this local first FM this podcast, and so this is Johannes Schickling, and so in fact I learned about the podcast because Matt One he was a guest on the podcast talking about CR SQLite. He mentioned to Johannes that that he had talked to me about Jinaga, and said, "Man, you should probably talk to Michael." And so Johannes reached out to me, and so we we're trying to set up an interview to so that we could talk about Jinaga on the website or on the podcast, but yeah, just listening back through these episodes, he's talking to basically each episode he's talking to most of the time a person who has created a solution, and it's like, what's unique about your solution, and a lot of times they get into how are they driving adoption, how are they getting people to try it out, and yeah, there's that's a really interesting side of it as well, because I'm having trouble
the marketing side.
Mm-hmm.
Yeah.
Yeah, but probably a great one to start with, Martin Kleppman.
Mm.
So episode 4. In fact, he was one of the authors of the local first essay, not manifesto. So yeah, he it was really this episode that made me say, oh, local first is different from offline first. It's got this extra pillar that is really powerful. So yeah, I started thinking about what am I doing with Jinaga that is local first that supports that pillar. um, and I think there's still a little bit of work to really get there, because yeah, you've got your local SQLite database, but you you can't easily hook another application to that SQLite database. Um, I mean, the API supports that. That database is not application specific, um, but but yeah, it still uh, takes knowing what the model is um, and then coding to that. And yeah, it's not like hooking up query analyzer to to a SQL database, and you can just say, "Oh, show me all the tables, show me the schema," and then I can start
Mhm.
figuring things out. Yeah, so I don't have that kind of discovery tool. Um, and then that SQLite database um, was created and managed by that application that you installed. Whereas for this to be truly local first, what we would want is um, a, a space in on your machine that you can start to install different applications into. Um, and yeah, this Jinaga can support that. It's just not uh, optimized for that.
Yeah, but you could do an export
Mm-hmm.
of all the facts, and then they are more readable. But um, or copy all the data in a traditional database with what was it, the outpost pattern? Was it that
Oh, the outbox. Um, yeah,
outbox pattern? Yeah,
yeah,
um, something in that sense.
yeah, yeah. If you use the outbox pattern, you're kind of implicitly changing the structure, and you're also making a decision about which parts you want to export. So yeah, it's a great integration pattern. But if you wanted to retain everything in exactly its format, um, you would want to use you would want to actually just connect it as an upstream and push all your facts to it. But I do see yeah if we could get to a point where we've shifted the business model, then um, I do see something that can really support that. Um, so imagine a world where, and this is actually what Tim Berners-Lee was talking about, because he's working on exactly this thing. So imagine a world where, as a user of of a computer system, you you subscribe to or manage yourself a Tim Berners-Lee calls them a pod, um, a um, something that retains all of your data. So think kind of like OneDrive, except OneDrive, Microsoft actually owns that server side, but you still have a copy of all your documents. But yeah, imagine that this is application data that you've got a pod that's on your device, but then you also have a pod that you own that is accessible in the cloud. It's addressable. Um, so it could be one that you rent from somebody, or it could be one where you just set up your own server and you run it yourself. And now all of your data from all of your applications go into your pod, and then up to your cloud pod. So that way you can have multiple devices. They could all be connected to the same pod. Um, and so yeah, data would just flow from one to the other. So yeah, yeah, Jinaga could support that if we just change the business model where it's not the developer who runs the replicator, but instead it's the end user. So the end user can go to a website and buy a replicator and then install their applications into it, or they could uh, grab their own server, take the Docker image, boom, start a replicator, and um, and now connect all of their devices to it. We would have to switch to the business model so that the developers still get um, still get compensated for building applications, but those developers wouldn't own your data. They wouldn't even own the replicator that your data is stored on. So, um, so you would install an application. You would say, okay, here's the address of my replicator, and now the replicator has your key store, so all of your identity is stored there. The app developer just ships an app. They don't even run a service anymore. Um, or maybe they do run a service. Maybe the app, like maybe this is a food ordering app. So maybe the app has some side effects. It's not just data, but when you order your lunch through the app, then it has to connect to another replicator in order to send your order up there. So maybe the developer or whoever runs that service hosts their replicator with some backend processing, similar
But,
to what we
but,
just saw.
but it means that the data model should be standardized.
Yeah, certainly the replicators can talk about directed acyclic graphs. They can talk about facts, but they don't know the schema except for authorization rules, distribution rules, and purge conditions. Um, so,
Yeah, but if the user owns the data, to be able to use it, the graph and the facts, the structure of the model should be known. And so if the application of another developer should be compatible, then that other developer has to know also the same.
Yes.
And everybody should use the same data structure. And indeed, the replicator is schema independent, but the development is not schema independent.
Yeah. Okay. Yeah, that's true. You do bring up a really good point. So there's two problems to solve there. One is that as an application developer, you don't just ship the client; you also write the authorization, distribution rules, and the purge conditions. So all three of those are expressed in specifications. So I've already got code that exports the authorization and distribution rules as text files, and you just load those into. Right now, the replicator is a service, but coming soon, you'll be able to load those into the replicator Docker image. So you stand that up, mount a volume, drop that file into that volume, and now it's behaving according to those rules. So I'll add purge conditions to that, and then there'll basically be one text file that has all three of these sections in it. That is the description of how the replicator should treat this application's data. So that that's deploying schema to the replicator, kind of like deploying schema to a database, except when you deploy schema to a database, it has to actually change the data in order to apply the schema. This is just rules on top of an application agnostic schema. And there's no code running, there's no application code running on the replicator. It's still a set of rules. So it's not like an API where you're deploying the code and you're checking, authorization headers. So, so once we've got that, then imagine being able to apply multiple of these files. So here's my replicator. I've grabbed the rules for this application and I've loaded it on my replicator. That application, load that onto the same replicator. So now it manages all my data, but those two applications have completely different models. So so they don't integrate. They're just both resident in that replicator. But then let's suppose that you've got a restaurant standard. So each restaurant runs its own little back end. So orders for this restaurant come in here, and I can see the list, and I can serve those. And then you've got lots of different restaurant apps that are competing, and so there's a subset of the schema that becomes a standard, and I don't have to control that. I can kind of set up an ecosystem and say, hey, here's how I suggest you come up with these standards. But then, yeah, basically,
Mm.
when the ecosystem takes over and people start creating these standards, they'll document the standards however they want to. I would prefer using a polyglot notebook, document the model,
Mm.
um, and then they would create a file that represents the rules for the common part, the standard part of the
Mm.
model. And so you would load that in, and then you would load in anything that's specific to this app. So, this app is able to order food, but maybe it's a party planner, so it does more things. But
Mm.
it's got the food ordering component to it. Um, and so yeah, I think a new business model, a new ecosystem, um, coupled with the foundational technology, can get us to a point where um, we're local first. People are owning their data. People are collaborating
Mm.
on how things integrate. People own their own services. They don't have to rent their services if they don't want to. Um, and if they do, they can still at any point take their data and move it to a different service because now it's a standard. And I think we can get to this local first ideal.
Yeah, but so people could propose a model, for example, for a restaurant business. But other people will take that model and collaborate, but you will always have these type of ego problems where somebody else say, yeah, but your model, I don't want it. I want my own model, which is
Yep.
better, um, which might be better, but is it worth to have a second one, which is 1% different and to create a chaos?
Yeah.
Um,
Yeah. I can't. I can't prevent that. I can kind of influence things. Uh, I can help that not become a problem. By uh, yeah. So if we kind of guide the world into um, having these standards bodies, like the IETF and W3C. Um, so I mean, the World Wide Web is a great example of this process eventually working. Um,
yeah.
browsers used to be all sorts of chaos, and they were trying all sorts of different things. And somehow through this this collaborative process, we now have a standard where we can reliably write code that runs on all the browsers,
Mhm.
and yet the browser vendors are still able to innovate. So, um, yeah, that's even at the level of infrastructure. So I mean, browsers and web servers are infrastructure. Um, I hear collaborating on a domain model in
Mm.
some domain that people have common interest in. It sounds a lot easier. Um, I know it's not easy,
Mm.
uh, but yeah, you, getting a subset of ordering food,
Mm.
because that's really a small. That's an example that fits in the book. It's really similar to the examples that are already in the book. Um, so getting a standards body to document that and get feedback and then say, okay, this is version 1.7 of this standard. Um, that seems like a very doable thing, and it seems like
Yeah.
vendors, application vendors, and service vendors would be incentivized to participate in that standards process, so that they, my restaurant uh, can support the catering business uh, for your event uh,
Yeah.
organizing app.
Yeah, because then the user is owner of his own data,
Mm-hmm.
and at the same time he can use multiple applications to integrate with his own data, and so he is not dependent on a certain provider or developer or company where he is locked in.
Exactly.
So
Exactly.
that would be nice.
Yep. Yep.
Hmm.
Now, how to get there? That's the problem. Um, Yeah, it's the classic fax machine problem. How do you sell the first fax machine? Who are you gonna fax? Um,
Mm.
yeah, you basically have to sell a suite of fax machines to one uh, one organization. So okay, you can
Yeah.
collaborate, and then I promise we'll sell fax machines to other people. So yeah, uh, I think you start um, by selling Jinaga to application developers. This is easier. One step before that, I think you start with build a suite of applications on Jinaga, and then um, you build them in such a way that those applications can work together. So somebody can install a to-do list app on yeah, on their phone. So okay, I'm using that, and then they say, oh, want to install a goal planner app. Oh, you know what? When I create goals, I'll create action items, and those will flow into to-do list and back and forth. So, oh, okay, that's useful. So you build a suite of applications that have common parts of the model, um, and uh, and then you open those standards and you say, hey, app developers, you can integrate with my suite of applications by following these standards and using Jinaga. Um, and that might be the thing that kind of first of all
Yeah.
kicks off sales, but then also kicks off
Yeah.
the
Or
ecosystem.
staying involved in the development of the models. Every time there is a developer who wants to develop something with Jinaga, to guide him or
Mm-hmm.
her so that the model reuses what exists already and adds non-existing things to it
Mm.
in
Mm.
a uniform way, so that because
Okay.
you might start with just an address. An address is used in every application, and then somebody needs some additional functionality.
Uh huh.
So you add it, and in the end you get the model of the world.
Yeah.
I mean,
Yeah.
um,
So if you're going to ship things to people, then here's the
mm,
subset of that supports that, and then whatever your application does. So maybe you're ordering
mm,
things from a store, or maybe you're ordering food from a restaurant. Whatever, you need to know addresses. So okay, and then now you use that
mm,
model, and you can integrate with the route finding applications and with the
mm.
with the logistics applications because it's all the same model. Yeah.
It's a little bit like, who was it? I think it was Martin Fowler, who wrote a book with a lot of models, typical business
Hmm.
problems, and models for it.
I'm gonna have to
Uh,
find that book.
yeah, I think it was Martin Fowler.
Hmm.
Um, and but that's a long time ago. But so it were typical business problems. Let's see whether I see his name
Analysis
somewhere.
patterns, reusable object models.
Might be that one. Yeah.
Look at that. Okay. That is going on my list.
Mm. Um, of course, that was a proposal for a model, but not a specific implementation.
Mm-hmm.
If you propose thing like that implemented on the Jinaga platform,
Yes.
that's another step forwards. Um, something like that, where you keep building on a model
Uh-huh.
so that developers don't have to reinvent the wheel, and the models are compatible.
I like where this is going. Yeah. So in order to get there, not only do I need to build the platform and the documentation and the training for the platform, but I also need to build this way for an ecosystem to emerge and a way for people to exchange models. Um,
Mm.
yeah, yeah, yeah. I can see that all kind of being part of the same experience. So yeah,
Where
as a
where you share the model with everybody,
mm-hmm.
but everybody keeps his own data.
Yes, yes,
You're the owner of your own data, but not of the model.
Excellent. I love this vision.
Mm.
Okay. Well, yeah. So next steps to get to to get to this place. Um,
Mm.
yeah. So yeah, I'm finishing up the purge conditions. I've got purge conditions working in .NET just barely.
Okay.
So so I think next week I'll be able to demonstrate that. But then, yeah, now I want to take a step back and take these three ideas, the authorization rules, distribution rules, purge conditions, um, and be able to extract that as a single file from your code, .NET code or JavaScript code,
Mm.
and then load that file into the replicator. Um, that'll solve one of the problems. One of the things that I want to do is to demonstrate a network of replicators. So so I should be able to create a Docker Compose file that starts replicators, loads different models into them, and then
Mm.
runs simple command line clients at the edge, and you type something in here, and you see boop, boop, it pings over there. Um, so so yeah, get that demonstration working, um, and uh, then that's basically the building blocks. Because now once you can do that with a replicator that you can deploy, uh, then um, then yeah, I can start saying, okay, here's a file for this model. I can refer back to Martin Fowler's book and say, hey, that model that he built
Mm.
there, here it is in Jinaga, and you know, see how you can use this to build other apps. And then, oh yeah, by the way, if you're using the same one as somebody else, you integrate.
Mm.
Yeah, a lot of
It's,
work to do, but the pieces are all there.
Michael found another challenge. Uh,
Oh yes.
yeah.
Yeah, then there has to be an experience where you can just go to jinaga.com and you can say, "Hey, I want to participate in this." Oh, okay. We'll walk
Mm.
you through, learning, about things. Here, try this out in browser. Okay, now, download this and try it in Docker Hub or in Docker desktop. Here, you know, try this in Visual Studio, that in Visual Studio Code, and whatever path you want to take.
Anyway, I was still looking through some code and had some questions about some functionality of some of the Jinaga functions. So I went back to jinaga.net, and I was surprised because it was a while ago, but it is nicely updated. Um, it's much more clear. You have the reference, you have
Oh,
the
good.
introduction text. It's uh, it's really getting a nice documentation now.
Oh yes, thank you, thank you.
Mm.
Yeah, I switch to this view. Um,
So I know you put a lot of work in it, and it went through a lot of iterations.
yeah,
But so already that is it's very nice.
yeah. This picture, yeah, this basically, yeah, the picture that used to be here was just old style, new style, and see how much you don't have to write yourself. But I'm like, no, no, no. I want to see. This is the vision. Um, replicators running in a network. Some of them are available to public applications, whether they be mobile or web. Others are serving backend services. And yeah, any fact that you create here, if there's a specification that is interested in that fact, it flows back there, um, and then it does something and publishes another fact that your mobile app is or your web app is interested in. It flows that way. Um, so yeah, that
Mm.
captures the essence.
Then the code samples below are also, it really gives you in a very limited reading, it gives you a good overview of the possibilities.
Yeah, yeah, thanks.
Um,
Yeah, now next I need to update this so that it's not using the facts repository, but
mm.
instead using the successors method. But uh, But yeah, that'll tighten this one up a little bit. But yeah, and then yeah, there's another part that I did some work on with the replicators. Yeah, I wasn't really calling out the fact that there are, yeah, first of all, what a replicator does for you. So it's like, without even reading, you see bullet points. You just glance at them and you know. So like, okay, that's what a replicator replaces for you. But then, yeah, these are the different kinds of replicators, or the different ways you could get one. Use the Jinaga portal, get a replicator as a service. Use the Docker image. Use the npm package. And instructions for each.
Mm.
And of course, it's simple to kind of simple to, all right, you got to do a lot of work yourself. But you have all three, and you can move from one to the other.
Yeah, and it leaves the power in the hands of the user.
Yep.
You can keep it simple. You go to the portal, and if you use the npm package or Docker, you have all the source code.
Yep. Yeah, because that's
So,
just the open
so you
source.
want, yeah.
Yeah. It's really just this code. All right, that basically, I just copied that from the the replicator source code. It's like, okay, I'm just using the npm package for you. Yeah, we are getting there.
Great. So next week, I told you, I guess I might be there, but I'm not not sure whether I will be back in time. So yeah.
Yep. Well, yeah, I'll plan next week to demonstrate the purge conditions in .NET,
Okay.
and then yeah, after that, then we'll probably have these model files loaded into the Docker image, and yeah, I can show that off. Maybe I'll even have that Docker Compose example working. That would be awesome. But maybe the week after.
Something for Christmas.
Yes, that's true. That would be a great Christmas present.
No, great. I might appear in the middle of the of your presentation. It depends.
Yeah.
Okay, and if not, then it will be the week after that I'm back.
Very good.
Okay,
All
Michael.
right.
Thank you very much, and probably perhaps next week, and otherwise the week after.
Sounds good. Yep. I will see you then.
Okay.
Thanks, Sean.
See you. Bye bye.
Bye.